right, so we're going to start dealing with polynomials and monomials. Shh, guys. All right, so section 5.1 is on monomials. So monomials are just one term. There's no, you don't have the term added to another term and so on. It's just all together. So it's an expression that's a number, a variable, or the product of a number and more than one or more variables. Monomials do not contain variables in the denominator, variables with negative exponents, or variables under radicals. So an example of a monomial would be something like 2x cubed, right? Or 1/2 xy to the third. You could have like square roots of, like square root of 35, x, y, z. Let's just do x, y, z like that. The things that you would not be able to have would be things like square root of x. So you can have the square root of a number, but you can't have the square root of a variable. You can't have like 1 over x. You can't have x squared minus 3. That would be like the sum or difference of terms. So just one term altogether. Michael, you with me? So things like that. And you can't have like x to the negative 2. That would not be a monomial either. Okay. So it says constants are monomials with no variables. Coefficients are the numerical factors of the number out front. And then the degree is the sum of the exponents of the variables. Okay, so if I have something like x to the 6th, the degree is going to be the highest exponent, or the sum of the exponents. So in this case, our exponent is 6. Okay, so we're going to talk about the degree, and our degree is 6. So the next one, I don't have any x value, right? So if I was going to rewrite this, it would be 14, and it'd actually be x to the 0. Okay, so we'll talk about a 0 power. A 0 power is actually 1. Like x to the 0 is the same as 1. So this degree then is 0. There's no x term. All right, so this one, these have a cubed and b to the 6th. So we had 3 and we had 6, so we're going to add those together. So the degree of this monomial is going to be 9. So what's the degree of the next one? 10. And what's the degree of the last one? All right, so this is different than when we talk about polynomials. So when I talk about a polynomial, so if I had like x to the 5th minus 4x cubed plus 2x minus 7. Okay, look at each individual monomial. We'd have a degree of 5, a degree of 3, a degree of 1, and a degree of 0. We don't add all of them together, okay? So our exponent, our highest exponent then would be 5. So the degree of a polynomial would be 5. It's just the highest one. So it's the highest degree of each individual monomial. Okay. All right. So this first part's going to be pretty much review. It does get a lot harder in this section, so make sure you guys are paying attention. So if I have something like 4 to the 7th, this whole thing is called a power. Did I to where I was before? Yeah, that one. Okay. So the whole 4 to the 7 is the power. The 4 part is called the base, and the 7 part is called the exponent. Do you guys remember that? So even I will mess that up. I'll say 4 to the power of 7, but I should really say 4 to the exponent of 7 or something like that. Okay. So the 4 is called the base, and the 7 is called the exponent. And when we write it out 4 times 4 times 4 times 4, etc., that's called expanded form. Okay, so it's important to recognize what is being raised to a power. So if I have negative 2x to the 4th, like this first one, the x part is the only thing that's being raised to the 4th. Do you guys all see that? Okay, so the base is just the x. So if I was writing it in expanded form, I would have the negative 2 out front, and then I'd have x multiplied by itself 4 times, right? But on the next one, if I have negative and then I have 2x raised to the 4th, right, I'm going to have a negative out front. My base is my entire 2x. So this is like a negative 1 out front, and then 2x times 2x times 2x times 2x. Okay, and then the next one, do you guys see the base for this one? Yeah, it's negative 2x, exactly. So it's going to be negative 2x times negative 2x times negative 2x times negative 2x. Oops. And all of these actually have different values. So if I went ahead and multiplied it all out, like simplified, the first one would be negative 2 times x times x times x times x. That's the one that is negative 2x to the fourth. This one would be 2x times 2x times 2x times 2x would be 16x to the fourth, but then I have the negative out front, right? So this one is going to be negative 16x to the fourth. And how about the last one? What do we think that one's going to be? Negative 2 times negative 2 times negative 2 times negative 2. Positive 16, yep, and then x to the fourth. So see how they're all different. So it matters what's being raised to a power. All right, so this next part is definitely review, I think, of Algebra 1. So it says write each expression using exponents, so go ahead and do it along with me. So the first one should be 3 to the 4. The next one should be 5 to the 3. X to the 5th. You guys all feel pretty good about these? Then I'm going to have 2 squared times 5 cubed. So I don't combine that and say like 10 to the 6 or anything like that. So the 2 and 5 can't be multiplied. And then this one's going to be negative 3 in parentheses squared times 2 cubed. All right. So this next one says write each number in expanded form and then simplify as much as possible. So now we're going to do the opposite. So we're going to write it out. So this first one is going to be 2 times 2 times 2 times 2 times 2. And then we'll go ahead and combine. So if I have 2 times 2 times 2 times 2 times 2, so 5 2's, do you guys know what that is? Yeah, 32. And this next one's going to be negative 2 times itself 3 times. So we're going to get negative 8. And then this one's a little bit different, so don't be tripped up. A lot of people mess this up. And I have a lot of people that come to me and they're like, my calculator told me the wrong answer. I'm like, no, your calculator is telling you what you input. So if you want to do negative 2 times itself 4 times on your calculator, you have to put parentheses, right? If you wanted negative 2 multiplied by itself 4 times. This is not what that is. So C is different. So it's a negative out front, right? So we'll put negative 1 and then times 4 of the 2's. So this answer should be negative 16. But if I had a negative 2 times itself 4 times, it would be positive 16. All right, so the next one should be 1/2 x times 1/2 x times 1/2 x times 1/2 x. So if you want to, you can always rearrange it so all the numbers are out front and all the x's are on the end. So if you wanted to, you don't have to do this. But you could write 1/2 times 1/2 times 1/2 times 1/2. And then times x times x times x times x. So we get 1 over 16 x to the 4th, right? Because 1/2 times itself 4 times is 1 over 16. It's not 2. That would be adding, right? 1/2 plus itself. All right, feeling pretty good about this still? So negative 1/3 x times negative 1/3 x. We'd have negative 1/3 times negative 1/3, multiply across the top and bottom. We get positive 1 over 9 x squared. All right, and then the next one, same idea. So I'd have negative 2, and then I'd have 1, 2, 3 a's, 1 b, negative 5, 1 a, 4 b's. So if I combine my numbers, I have negative 2 times negative 5 gives me positive 10. And then I have 1, 2, 3, 4 a's. So I'm going to have 10 and then a to the 4th. And then I have a total of 5 b's, so b to the 5th. Okay. Do we feel good about this? Thumbs up? Everybody feels good? All right. It's going to get harder in just a little bit. All right, so we have all these different properties, and I'm sure that you guys all remember these, or have seen these properties, but I don't know if all of you remember every single one of these. So the first one is the product of powers property. So it says to multiply powers with the same base, we add the exponents. So if we have like 2 to the 5th times 2 to the 3rd, think about it in expanded form. We'd have 2 times 2 times 2 times, we'd have it 5 times, right? And then we have another 3 times, so we get a total of how many 2's? To 8. So 2 to the 8th. So just like with x's, if I have x to the 5th times x to the 15th, I would get x to the 20th. So we're thinking about expanded form. So quotient of power. So let's say I have x to the 5th over x to the 2. All right, in order to do this, we subtract the exponents. So what we think of this as is 5x's on top, 2x's on the bottom. And just like with fractions, you know, if I had like 16 over 10, I think of it as 2 times 8 over 2 times 5, and I reduce out anything in common on the top and the bottom. The 2 and 2 reduce out. That's what I'm doing on things like this. So if I have 2x's on the bottom and 5 on the top, then I'm going to cancel 2 on the top and the bottom. So I end up getting x cubed. That is typically how I teach my students to think about this. Think about it in expanded form. Where are they left? Because it gets a little bit confusing when we have the other direction. So if I had x to the 4th over x to the 8th, let's say. Yeah, if we do the subtraction thing, it's x to the -4, and then it's confusing. It's like, wait, do I put the -4 on the bottom, on the top? Where do I put this? So what I always tell people to do is think about expanded form. If you have 4x's on top and 8 on the bottom, I should have chosen a smaller number, like that, then we can reduce out 4 on the top and 4 on the bottom. And when we reduce a fraction like that, what's left on the top? 1, right? So this ends up being 1 over x to the 4th. Does that make sense? So that's how we're going to be doing that. Think of it in expanded form and then reduce out. We don't have to write it out every single time. All right, so powers of a power. So if I have x to the 5th, well, that's okay. And then I square it. Right, what that is, it means x to the 5th times x to the 5th, right? So if it was in expanded form then, I would have 5x's lined up. I'd have another 5x's lined up, so I'd have a total of how many x's? 10. Okay, so what we do from the beginning, instead of writing it separately, is we could just multiply the 5 and the 2. Okay, so when we multiply 5 and 2, that's how we're getting 10. Okay, and then a power of a product. So if I have x squared y to the 5th, and then I raise it to the 3, that 3 goes into both pieces. So I'm going to have x to the 6th, and I'm going to have y to the 15th. Kind of like the distributive property. That's what everybody always says every year when I do this. It's like the distributive property. So it goes to both of those pieces. And why is that? Because if I had it to the 3rd, I would multiply that whole thing by itself 3 times, and then I could think about expanding it, right? All right, and then the power of a quotient, same idea. If I have x to the 8th over y to the 3rd, and I square it, what do you guys think we'd get? X to the 16, y to the 6. Okay. Still okay? All right, so let's practice. So you have a couple examples, so go ahead and try them along with me. Make sure that you're getting these. So I have 5 to the 3 times 5 to the 4. So think about it in expanded form. I'd have 5 times 5 times 5, and then I'd have another 5 times 5 times 5 times 5. So how many 5s do we have? 7, exactly. So we have 5 to the 7. The next one, we could rearrange all of the terms. I have a 5 out front. I'd have x cubed and another x cubed, so I have x to the 6th and then y to the 4th. Okay, so these are the types of things that you definitely did in Algebra 1. Okay, so Algebra 2 is always a little bit of a step up. We review what we did, and then we do a little bit harder. So this next one, if I had x cubed y to the 7th over x squared, imagine the x's on top and bottom. We have 3 x's on top. We have 2 x's on bottom. So 2 are canceling on the top and the bottom. Whoops. So we're going to be left with an x on top and a y to the 7th. And then I could write a 1 on the bottom, but I'm just going to leave it. So I could say xy to the 7th all over 1, or just xy to the 7th. Okay. Still feeling good about this? What about the next one? Anybody know what this one is? Yeah, x to the 8th times y to the 12th. Perfect. Okay, so the next one involves something to the 4th. You could raise it to the 4th, like take every single power and raise it to the 4th now. Or you can simplify first and then raise. So I'm going to simplify first. You don't have to do that. It just makes it easier if you have smaller numbers, or if you have lots of big numbers, I guess. So if I have an x and I have an x squared on the bottom, how will those reduce out? You could subtract, but we don't want to do negatives, right? So if I have x on top and I have x squared on the bottom, Becca, what do we get? Exactly. So she says just one x on the bottom, right? Then we still have the y squared, we still have the z on the bottom. And it's still raised to the 4th. So now we raise each thing to the 4th. So we're going to say y to the 8th over x to the 4th, z to the 4th. Okay, and the reason those are to the 4th is because these powers that we had before, the x and the z, are really x to the 1, z to the 1, right? So when we multiply 1 times 4, that's how we're getting the 4. Okay. Do you guys want to try the next one? Go and try it. See what you get. I would probably simplify first. So when we simplify on the inside, we have a squared on top and we have b on top. So that means it's really just a 1 on the bottom. You don't have to write the 1 though. So if you instead wanted to erase that and just write it like that, that would be totally fine. And then we raise it to the 3, so don't forget that this is b to the 1st power. If you need to put the 1 in, that's fine. So we end up getting a to the 6th, b to the 3. And that's our answer. Okay, so far, I mean, it might be a little bit of a stretch, like remembering every single detail from Algebra 1, but so far I think this is pretty good for you guys, right? Still feeling pretty good? All right, so let's get into some more challenging ones. So the zero exponent property. So it says a non-zero quantity raised to the 0 power is equal to 1. So why is that? Okay, so let's think about one that we know. So if I said x cubed divided by x cubed, right? We said that was x times x times x all over x times x times x. So what does it end up being? 1, right? So this is all equal to 1. However, what if I use the subtraction property? So remember how I said, like, if I had x to the 5th over x squared, I subtract my powers, x to the 5 minus 2. It's x cubed. What if I do that here? I get x to the 3 minus 3, which is x to the 0. So in other words, 1 is equal to x to the 0. So anything to the 0 power is equal to 1. I should be kind of careful saying that, because actually 0 to the 0, we don't know what that is. It's undefined. There's a big debate about it. Is it 0? Is it 1? There's not really a big debate. It's just neither 1. Okay, so 0 to the 0, we don't say it's anything. So if I have something crazy and it's like 3x squared y over 5z to the 5th, all raised to the 0. Yeah, that whole thing is raised to the 0 power, so that whole thing is equal to 1, right? All right, so how about the negative exponent property? So we'll do something similar on this. So what if I had x squared over x to the 5th? If I subtract my powers, 2 minus 5, I get x to the negative 3. But that's not the way I was telling you to write it. I was saying it's easier to think about it in expanded form. If you have 2 x's on top and you have 5 x's on the bottom, when you cancel, how many x's are going to be left and where will they be left? You'll have 3 on the bottom, right? So really, this is all equal to 1 over x cubed. Does that make sense? So 1 over x cubed is the same as x to the negative 3. So if you have x to any negative power, just do 1 over and then put the positive exponent. Yeah. I like positive exponents in the end. So yeah. All right, so what if you have a fraction? So it says a non-zero base raised to a negative exponent is equal to the reciprocal of the base. So if I had something like 2/3 to the negative 4, that's kind of weird. We don't want to do like 1 over a fraction, right? That would be really strange. So instead what we do is we flip the whole base and write it as 3 over 2 and then raise it to the positive 4. Okay, so it says fill in the following table and answer the questions on the right. So 2 cubed is 8, 2 squared is 4, 2 to the first is 2. Do you see the pattern? 8, 4, 2. So 2 to the 0 is 1. 2 to the negative 1? Yeah, it's 1 over 2. 1 over 2 to the first, right? The next one is 1 over 2 squared, so 1 over 4. Keep dividing by 2, 1/8, and 1 over 16. So that's why 2 to the negative 4 is 1 over, right? That whole thing is 1 over 2 to the 4th, which is 1 over 16. It follows that pattern. So do negative exponents mean that the number is negative? So if I had 2 to the negative 4, was my output, was it negative? No, I had a positive number in the end, so no. It is just the reciprocal. I don't know how to say this, but I'll say of the positive exponent. So if I raise the whole thing to a positive number, it's a reciprocal. So what does any number raised to the 0 power? 1. And then what do you notice about 2 to the 3 and 2 to the negative 3? They're reciprocals, exactly. Okay, so this is where it starts to get to be a challenge. Okay, and this is where I think it's a lot different than Algebra 1, unless you had a really good Algebra 1 teacher that was really showing you this stuff. All right. So if I have 4 to the negative 3, so we just said 4 to the negative 3 is 1 over 4 to the 3. 4 to the 3, 4 times 4 is 16. 16 times 4 is 64. So this whole thing is 1 over 64. 16 times 4. So 4 times 4 is 16. 16 times 4 is 64. As a math teacher, I know lots of squares and cubes. All right, so x to the negative 2. So I get 1 over x to the positive 2, right? But if I already have a fraction for my base, it's not easy to do a 1 over a fraction. So you could do it this way where you say 1 over 1/2 to the positive 2. That's kind of gross. It takes a long time. It would work. You get 1 over 1/4. 1 divided by 1/4 is 1 times 4 over 1, which gets you 4. But that's a lot of work. Okay, so the easiest way to do these ones is to flip the base. So I'm going to write it as 2 over 1 raised to the positive 2. Well, 2 over 1 is 2, so 2 squared is 4. Much faster, right? So if you already have a fraction for your base, just flip the whole fraction. How about number 4? Do we all know that one? Yeah, it's all raised to the 0. What about number 5? Ah, be careful. Part of it, this part's 1, right? So we have 2x times 1, which is going to be 2x. I tricked you. All right, so the next part we have raised to the negative 3. So it's already a fraction, so let's just flip the base. So it's going to be y over 2x raised to the positive 3. Okay, so everybody always gets, like, they would get the y cubed and the x cubed. For some reason, I would say about 25% of my class every single year forgets the 2. So what do we think the 2 is going to be? 2 to the 3, which becomes 8, right? So don't forget about the 2. The 2 is going to be cubed as well. Right, because what is it? It's y over 2x times itself 3 times, so we still have that 2 times 2 times 2 there. So always think in expanded form if needed. All right, so the next one, we're going to flip the base. So we're going to get b squared over 3ab, and we're going to raise the positive 2. And then from here, you can do lots of things. You can simplify on the inside and then square, or you can square everything and then simplify. It doesn't matter. I tend to simplify first, just in case we have some messy numbers. Okay, so how about the b squared and the b? Yeah, so b on the bottom, b on the top go away, so I get b over 3a, and then I square it. So when I do b over 3a, and then squared, it's b over 3a times b over 3a, so I get b squared over 9a squared. That's my answer. All right. You do. The 3 times 3 is the 9. Yeah, that makes sense. All right, so what if we have lots of weird things? Like this one has negatives inside the problem. Okay, that's kind of weird. Okay, so you can do the subtraction rule if you want to. Here's my trick. Okay, this will make it a lot easier. Do you guys get a little overwhelmed when you see like negatives in the top, negatives in the bottom? It's a little overwhelming. So the way to make this easier is to move anything that has a negative exponent to the opposite location and make it positive. Okay, so anything with negative exponent moves to opposite side and becomes positive. So I can show you why that's true. It takes a while. It's kind of like that one that I did, that was like 1/4 raised to the -2 or something like that. But basically anything that has a negative exponent would end up being 1/x³. Well, 1/x³ puts the x³ in the bottom. Okay, so this x to the -3 is going to go to the bottom as x³. You leave the 5, yep, because it's not being raised to a negative exponent, right? And then do you see anything else that has a negative exponent? Y to the -2, that's going to move up and become a positive. So we're going to rewrite. So I'm going to keep my 5 where it is. I'm going to keep the x to the 5th where it is. I'm going to keep the y³ where it is. I keep my 15 and my x to the 0 where they are. And what did I move? I moved that x to the -3 as an x³ to the bottom, right? It was on the top, x to the -3, and I put it on the bottom as x³. And then I can move that y to the -2, I can move that to the top as y to the +2. Okay? It's still all raised to the +2, just like it was before. But does it look easier now? Yeah, it looks a lot easier. Yeah. Yep, so we're combining. So how about the 5 and the 15? Let's start there. Yeah, they reduce out just like normal, 1/3. They're just like a fraction. Don't subtract don't subtract them or anything, thinking, oh wait, these are like exponents. They're not. They're just regular numbers. 5/15 is 1/3. All right, then we look at our x's. So I have x to the 5th. What about that x to the 0? That's all 1, so I'm just going to cross that out. So I have x to the 5th on top, and I have x³ on the bottom. Imagine 5 x's on top, 3 x's on bottom. How many would I have left, and where would they be? 2 on the top, right? So I'm going to have my 1, and I'm going to have my 3 from before, and then I'm going to have x² on top. How about the y's? How many will I have on top? 5, y to the 5th. And then I'm going to raise it all to the 2. So square everything inside. So 1 squared is just 1, x² is x to the 4th, y to the 5th squared is y to the 10th, and then don't forget about that little 3 down there. 9, exactly. All right, and then number 9, if you can do number 9, you can do all of them. So number 9, I have 36, a to the -6, b to the -5, c to the 3, all over 45, a to the -5, b to the -3, all raised to the -2. So let's work on the inside first, and then we'll deal with the -2 at the end. What do you think the -2 is going to do? Flip everything on the inside and then raise it to the +2, right? So we'll deal with that at the end. So how about our 36 and 45? Do they reduce out? If I had 36 over 45, would you leave that as your fraction answer? No, they're divisible by 9, right? So let's divide by 9. So we get 4 and 5. Maybe I should move things first. All right, so now we're going to move. So the a to the -6, the b to the -5, the a to the -5, and the b to the -3 are all going to move. There's a lot of movement going on in this one. All right, so we're going to get a to the 6th on the bottom, b to the 5 on the bottom. What about that c³? It's still on top, right? And that a to the -5th that was on the bottom is now a to the 5th on top, and b to the -3 that was on bottom, now b to the 3 on top, right? And still raise the -2. Yeah? No, like I just put those where they were, but they could be wherever. Yeah. Just as long as they're on the top and the bottom. It doesn't matter where they're lined up. All right, so I'm going to have 4, and I'm going to have my 5 still. how about the A's? Looking only at the A's, I have 5 on top, 6 on the bottom. So if I reduce them out, I'm reducing out 5 on the top and the bottom. I have 1 on the bottom. And then my B's, how many B's do I have, and where are they? B squared on the bottom. Do you guys see that? 3 on top, 5 on bottom. 2 left on bottom. And then my C cubed stays where it is, raised to the negative 2. So we're going to flip the base. And we're going to raise to positive 2 now. So when I flip the whole base, I'm going to write my 5ab squared all over 4c cubed, all raised to the negative, or now to the positive 2, right? I changed my power. Instead of negative, I now have positive because I flipped everything inside. Took the reciprocal. So final step, raise everything to the 2. So I'm going to have 5 to the 2 is 25, a squared, b to the 4th, all over 16, c to the 6th. And that is my answer. Yeah.
So when you were doing it last and then you distributed the 2 to the b over 3a, why did you get 9a on the bottom? Wouldn't it be
because, well, no, because from here I would think of it as b over 3a times b over 3a. Does that make sense? Yeah. So 3 times 3, yeah. Yeah, a lot of people will do 5 squared and they'll write 10 because they're so used to doing the exponents by multiplying, so be careful with things like that. So the numbers are just like normal. All right, so we're going to stop here. I'm going to pass out your homework. But we hadn't quite done to the scientific notation. So hopefully the idea of scientific notation is not new to you. You've seen this before. So scientific notation is a method of writing numbers using powers of 10. It's used when we deal with really, really big numbers and really, really tiny numbers. So if we're talking about the weight of a planet, or if we're talking about the weight of an atom, we would use scientific notation, okay? It also makes multiplying and dividing with really huge numbers and really small numbers very quick. So we do this a lot in science classes in particular. So I don't really tell my students to move to the right and move to the left and so on. I really just tell them to know whether or not you have a really big number or if you have a really small number. So really huge numbers are going to have positive exponents. Really small numbers are going to have negative exponents, okay? So we will talk a little bit about the right and the left, but don't try to memorize that because then people will mess it up when going from scientific to standard and then standard to scientific. They just get them confused, okay? So the first one, it says change to scientific notation. So if we have 1,300,000, is this a big number or a small number? It's a big number, right? So when we are writing this in scientific notation, we're going to first try to get our number. Do you guys remember between 1 and 9.999? So basically there's a 1 number and then a decimal point, not 0 and then a decimal point. Okay, that's the rule. So we're going to move our decimal place over, and we're going to move it 1, 2, 3, 4, 5, 6 places to make that number 1.3. And then the 6 goes on the power. So we do 1.3 times 10 to the 6th like that. You guys all remember that? Yeah. So if I'm changing 250, it's not a tiny little decimal number, it's a big number. So we move our decimal place over 1, 2 places, and that puts it so that it's 2.5, and then we do times 10 to the 2nd because we moved it 2 places. Okay, this next one is a tiny little decimal, so we have to move it. We're going to move it so that we have 5.6. Right, we want that number between 1 and 9.999, right? We want one number before the decimal point. So we're going to move it over 1, 2, 3, 4, 5, 6, 7. So it's going to be 5.6, and it's a tiny little decimal number. So we say times 10 to the negative 7, like that. It's a negative exponent. Remember, negative exponents do not mean that the number is negative, right? It just means that it's a tiny little number. It's like reciprocal. All right, so this next one I have 0.3. So I move it over 1 place, so I get 3. You can write 3.0 if you want. And it's times 10 to the negative 1. Okay, so let's think about what that means. 10 to the negative 1 is 1/10. If we have 3 times 1/10, that's 3/10. Is that the number that we had? Exactly. That's why the negative exponents work the way they do. It's like dividing by 10 or 100 or 1,000. It's moving the decimal place. All right, so the next one. So go ahead and try these along with me. See if you get the right answers. So we moved over 1, 2, 3, 4 places. So I'm going to have 2.5 times 10 to the 4th. The next one I'm going to go 3, 6, 9, 10 places. So I'm going to have 3.89 times 10 to the 10th. Michael, you with me? I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places again. But now this is a tiny little decimal, right? So it's going to be 4.5 times 10 to the negative 10. And then the last one is 6.89 times 10 to the negative 1. We move it over just one little space, right? Okay, is that all familiar to you? You've all done this before. Okay. All right, so just like that, if we have scientific notation, so we're changing from standard to scientific, we can change from scientific to standard. So I guess I didn't do any of those examples. I just went ahead and did the multiplying and dividing. Okay, so scientific notation makes multiplication and division of large and very small numbers much simpler. Okay, and this is the type of problem that you guys have on your homework, so the multiplying and dividing. And it uses the rules of exponents that we've been talking about, okay? So if I have 3 times 10 to the 2nd times 2 times 10 to the 4th, what I do is I really think about the 3 times 2, and then I think about the things with powers, 10 to the 2nd times 10 to the 4th. Well, 3 times 2 I know is 6, and 10 to the 2nd times 10 to the 4th is 10 to what power? 10 to the 6th, exactly. So see how quickly you can multiply and divide. So same idea on this one. If I have 1.4 and 2, 1.4 times 2 is 2.8. And then if I have 10 to the negative 2 times 10 to the 4, let's think about it. 10 to the negative 2 times 10 to the 4. You can move that 10 to the negative 2 on the bottom if you want, or you can just add their exponents, right? If you add the negative 2 and the 4, what do we get? 2. So we get times 10 to the 2nd. If you want to do the thing with negative exponents where you put it in the opposite location, that works as well. 10 to the 4th divided by 10 squared is also 10 to the 2. Okay? All right, so it does get a little bit trickier. So if I have 7.6 times 2, do you guys know what 7.6 times 2 is? 15.2. So we're going to have 15.2 times 10 to the 20th. Okay, these are the ones that you probably didn't do in Algebra 1. Okay? So let's think about it. 15.2 times 10 to the 20th. Is this in scientific notation? It's not. What's wrong with it, Kenzie?
It's bigger than 9.
Yeah, that 15.2, we need it to be 1.52, right? It's bigger than 9.999 and so on. Okay? So we need to change it. So there's a couple different ways that you guys can do this. Okay, so what you could do is you can change 15.2 and you can say, well, I know 15.2 is 1.52 times 10 to the 1st. And then when I multiply by 10 to the 20th, I have 10 to the 1st times 10 to the 20th, so my final answer is 1.52 times 10 to the 21st. So you can do it that way. But the way that I like to think about it, without writing all that work out, is I say, oh, if I'm multiplying by 10 to the 20th, that means that I'm going to take this decimal point and I'm going to move it. So I'm going to move it over 20 times, right? So I'd go over 1, 2, 3, 4, 5, 20 times. But then if I brought it back, how many times would I have to bring it back so that it's not right here, but instead right here? 21 times. Do you guys see how we get the 21? So that's kind of a good way of thinking of it too. Say, okay, well, I go out 20 times, but then I have to come back 21 times. So it's going to be 1.52 times 10 to the 21st. All right, and then same idea with division. So I have 9 divided by 3. 9 divided by 3 is 3. And then I have 10 to the 3rd divided by 10 squared. That's going to be 10 to the 1st. So it's 3 times 10 to the 1st. We typically do put a first when we do scientific notation. All right, the next one is going to be 3 times 10 to the what power? 5th. We subtract our exponents, exactly. And then this one's a weird one. So 8 divided by 16 is 1/2. I'm not going to write it as 1/2, though. I want to write it so I can see the decimal. So 0.5 times 10 to the trick question. It is 12, right? Because this 10 to the negative 4 would go up as 10 to the 4th. Or you can do 8 minus a negative 4, and you get 12. All right, so we're going to have, yeah.
How do you get the exponents on 4 and 5?
Oh, I subtracted my exponents. So if I had 10 cubed over 10 squared, it's just like if I had x cubed over x squared, you'd subtract. All right, so if I have 0.5 times 10 to the 12th, let's use that trick I was talking about. If I have 0.5 and I move it over 12 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, how many times do I move it back so my number is between 1 and 9.999? Yeah, I move it back right here, right? 1 less, so it's going to be 5 times 10 to the 11th. So if you don't like that method, you can always do what I did before. You can rewrite 0.5 and you can say, oh, 0.5 is 5 times 10 to the negative 1. And then I still have times 10 to the 12th, so I just add those numbers, negative 1 plus 12. Okay, making sense? Maybe? Okay, questions on any of that? All right, so quickly, let's do a couple more review problems of what we did yesterday. Yeah? Don't you wish? So go ahead and flip to, at the end of the chapter, I have some additional notes. We're going to try a couple more examples. So I think the things that were throwing you off are the ones that I had negatives in there and things inside parentheses. And let's just do y to the 5th. Okay, so let's say we have something like that. Okay, so try along with me. Be active note takers. I always say this. So try the problem along with me and see if you get the correct answer. So we're going to write in parentheses negative 2x raised to the 3, and then in parentheses 3y, all raised to the 2nd, and then all over 8xy to the 5th, x to the negative 4. It's a long chapter, isn't it? Chapter 5. Are you finding the end of your notes? It's a long one. Lots of stuff in chapter 5. All right, so when I have negative 2x all raised to the 3rd, I do negative 2x times negative 2x times negative 2x. Okay, so what am I going to get for just that part? How about Nick? What do I get? Negative 2x times negative 2x times negative 2x. Not 16, close. Negative 8. So negative x cubed, 8x cubed. All right, Jacob, how about the next one? 3y squared. 3y times itself.
Oh, 9y squared.
Uh-huh. And then I still have my 8x, y to the 5th, all over x to the negative 4. All right, so my negative 8 out front, that does not move, right? Negative 8 does not have a negative exponent. It stays right where it is. But I do have my x to the negative 4th. So we're going to move positions, and we're going to make it x to the 4th. So I'm going to have my negative 8, my x cubed, my 9y squared, and then all over 8xy to the 5th. And that x to the negative 4th is now x to the positive 4 on top. All right, so I look for things that are going to reduce. So my negative 8 and my 8, those do reduce down. What am I left with? Negative 1, right? All right, and then my x's. So I have x cubed, I have an x to the 4th on top. So I get a total of how many x's on top? 7, and then I have 1 x on the bottom. So I'm going to have 6 left on top, right? So I'm going to have a negative 1, and then I'm going to have an x to the 6th. I still have my 9, and then I have a y squared and a y to the 5th. So what's that give me? Y to the 3rd on the bottom, exactly. So my final answer is going to be negative 1 times 9, so negative 9, x to the 6th all over y to the 3rd. Did we all get that? Okay, do you guys want to try one more? Does it help that I say you have a quiz tomorrow on this? Does that make you want to do one more? Yeah, Zach's looking at me like I just said the worst thing in the world. All right, so let's do this. So let's say I have 8x to the 5th, y to the negative 2, z to the negative 3, all over 2x all raised to the 4th, y to the negative 3, z to the 16th, all raised to the negative 2. About as hard as I get, guys. If you can do this one, you can do any of them. So it's one step at a time. We do not panic. one little thing at a time.
That's the first step.
First step, panic. So let's handle these inside parentheses first. If I have 2x raised to the fourth, so it's 2x times 2x times 2x times 2x. Eric, do you know it? 16x to the fourth, exactly. So I'm going to replace that with my 16x to the fourth. All right, do you want to do the negative exponents right now too? So I have y to the negative 2, I have z to the negative 3, and I have y to the negative 3. So it looks like that x to the 5th stays where it is, and that z to the 16th stays where it is, so I'm going to put that in. But anything that I just circled in blue is going to move. So that y to the negative 2, when I take its reciprocal, it puts it on the bottom as y to the positive 2. So I'm going to have y to the positive 2. I'm going to have my z to the positive 3 on the bottom. And then I'm going to have y to the positive 3 on the top. And it's all raised to the negative 2. Yep, so we're going to try to simplify on the inside. Oops. So when I simplify, Eric's saying let's take care of the 8 and the 16 and reduce that down because we don't want to raise things to the 2 and then reduce, right? We would much rather reduce first. Okay, so I'm going to have a 1 and a 2. And then I'm going to deal with my x's. So I go through and I'm like, okay, I have x to the 5th. I have an x to the 4th on the bottom. Yep, so an x on top. And then I'm going to go through and look for my y's. So I have a y cubed and a y squared. So I get a y on top, right? And then how about my z's? Z to the 19th, exactly. And we're all raised to the negative 2 still. So now what do I do when I have a negative exponent on the outside? Yeah, you can take the reciprocal of everything on the inside. So when I take the reciprocal of everything on the inside, I have 2z to the 19th all over 1xy, and I'm raising it to the 2. You don't really need the 1 there, right? 1xy. So 2 squared is 4. How about z to the 19th raised to the 2nd? Z to the 38th all over x squared, y squared. That is your answer. Does it make more sense today? You feel better about it. All right. All right, we're going to stop there.